In this chassis design, we depend on suppliers for some of the components. Now, many of these suppliers use other 3D CAD systems, so we need to be able to easily import their non-solid edge 3D data and make edits where needed. So let's go ahead and import our first component. And when I say import, in fact, all we need to do is click Open, like you would do in opening any other file. You can see here the many file types. Solid Edge can open files from other Siemens software such as NX, universal CAD formats such as Parasolid, STEP, IGES, and even other CAD systems such as Inventor, Pro Engineer, SolidWorks, etc. SolidWorks, this first component is from that system, so let's open that right up. Now we can easily apply a material as well as a finish. And in this case, our component is going to be painted orange. So importing was the easy part. What about the edits we need to make? Most other CAD systems rely on a history to be able to edit a model. But obviously, as this wasn't created in Solid Edge, we don't have that history, as you can see in the tree or lack of it on the left. Not a problem, and no need to do any convoluted feature recognition. Synchronous technology in Solid Edge allows us to make edits with a simple push and pull. This couldn't be any easier or intuitive. Click on a face and drag, and notice how the other faces that are in line with this are moving too, just as if it was a feature in a history tree. But what if you prefer editing existing dimensions instead? Sure, just click a face and Solid Edge will give you the dimension of that feature on the fly, ready to go to edit. Again, notice the intelligence of all the other holes changing as if it was in a pattern. I know, it looks like magic. If you want to add your own dimensions, you can do this in 3D. No need for sketch work. We need to set this thickness at 6 millimeters. Notice the control we have to keep this top face fixed. Now, one good reason for having a history of features in a tree is when we need to reorder rounds. You can see here that the previous designer created 2 rounds in the correct order, but these 2 incorrect with the wrong blend. Can we solve this in Solid Edge without a history? Absolutely. A simple right click to reorder. Now, while we're here, we need to change the size of these rounds. By selecting one of these rounds, Solid Edge can automatically seek out other rounds in the same size. This way, we can save a lot of time by making one edit, not multiple. In some cases, though, you may need more than a dimension to edit, a good example being holes. Here we can tell Solid Edge to recognize these circular cutouts as holes so that we can change to a specific hole type. And in this case, we need counterbore holes here. You'll notice it added the holes to the history tree. And as I walk over here and expand, you'll see that each one of the holes were created individually. What about removing geometry? Well, that's as intuitive as deleting files in Windows System. All we have to do here is simply fence select, and then with the quick right mouse button we can delete these features. So hopefully you can see how flexible Solid Edge is editing non-Solid Edge parts. By simply here selecting a feature, we can easily make modifications and Solid Edge will do the rest. Now here, of course, we're just showing off a little bit. Let's go ahead and save these changes that we have made. Now the next step would be to simply drag this directly into our assembly design, where we can position it with the rest of the assembly. Solid Edge offers tools that allow the user to easily get parts into the design. Now we do have other components to bring in, so let's just get this part close to its desired location. That looks good. Now our next component, a sheet metal bracket, was sent to us as a universal CAD file, Parasolid. We can import this in exactly the same way we did with the adapter. A simple file open. Now again, we have options to apply materials as well as different types of finishes. Now because it's a sheet metal file, of course we want it to look like a sheet metal file. Now, not only did we receive the 3D sheet metal file, but also its manufacturing drawing in DWG format. Wouldn't it be great if we could make use of this drawing to assist us with any edits and also provide the tolerance information all in 3D? Well, check this out. Once we open the DWG file inside Solid Edge Draft, we can then use a tool to get us to help us get this done. In this case, we're going to grab the information we need by fence selection and then apply that information to our 3D model. Now, you've already seen the steering wheel in action when we move geometry around. It can be used in the same way to snap the drawing views into position on this model. So, nice to see the manufacturing intent overlaid in 3D, but wouldn't it be great if we could control the model with these dimensions? Synchronous technology in Solid Edge can do just that. A simple click to attach the dimensions, and now these dimensions are now live. Let's make some required changes. We're going to extend the flange to 35 millimeters, and then we can open up this flange to fit over the frame. We'll set it at 51 millimeters. Easy as that. So that we can send this to manufacturing, we need a flat pattern. But because this wasn't created in Solid Edge, how are we supposed to get this? Go back to the supplier? No, not a problem. We can tell Solid Edge to treat this as a true sheet metal part, flanges and all. This way, the correct bend allowance, etc. is known, so very quickly we have an accurate flat pattern. Now, back at the assembly level, let's go ahead and place this sheet metal file that we just created into position using the Assemble tool. Same tool as we used before. Now, the beauty of this tool is that it determines what type of geometry you select and then automatically filters the next assembly selection appropriately. This makes it very easy to get your components into position and fast. We can grab the cylinder. It's going to automatically align to the cylinder that we select. Here we want to get these two components placed into their correct position, so we'll first apply a mate and then finally an alignment, and it locks them into position. Now finally, let's get the drive motor attached to the assembly and then placed into its position. Notice the file name of this. Like the other components we've been working with, this isn't a Solid Edge file either. It's from Inventor. Using the same Assemble tool, we can quickly identify faces to mate and cylinders to align, making sure that our three new parts are locked into their proper position. And you can see that they are now. So once the motor is in its position, we can see right away we have a mounting problem. The two flanges don't match at all. No problem. With Solid Edge, a simple in-place edit allows us to grab geometry, sizing from one part and using it on another part. Now they match exactly, just as we would expect. We obviously need more room for fastening hardware. So let's go ahead and make some quick changes. Now first, let's get more room between the motor and its flange so we can add 20 millimeters to the throat. Just by fence selecting the geometry, keying in 20, it's going to move that geometry over for us. Now we need to change both parts together. Yes, that's right, a SolidWorks and Inventor part edited at the same time. At the assembly level, using the same simple push and pull we used before. So there you have it, synchronous technology in Solid Edge, allowing you to work with non-Solid Edge data as if it was Solid Edge data, importing just an open, editing just a push, pull, or delete, and you can even make use of 2D drawings along the way.